This video presents the paper, Modular Approach to Data Preprocessing in ALOHA and Application to a Smart Industry Use Case. ALOHA project proposes an integrated tool flow that tries to facilitate the design of DL applications and their porting on embedded heterogeneous architectures. The framework supports architecture awareness, considering the target hardware from the initial stages of the development process to the deployment, taking into account security, power efficiency and adaptivity requirements. You can find more information on the project website. Reply validated the approach in the industrial environment, using the ALOHA tool flow to deploy an embedded keyword spotting system on a IoT board, sensor tile from STMicroelectronics and control by voice a robotic arm, EDO by Comau. Sensor tile is a tiny IoT module by STMicroelectronics, based on STM32L4 ultra-low-power microcontroller with ARM Cortex-M4 core. It includes a MEMS audio sensor, omnidirectional digital microphone and 128 kilobytes of RAM. The DL models are trained using the Google Speech Commands dataset. In detail, we evaluated the ALOHA tool flow on two possible implementations of the KWS use case, one with 6 classes and one with 13 classes. Both the implementations use one class to identify silence or noise and another class for unknown words, which are all the other words in the dataset that are not used in another class. The first implementation uses the 4 keywords yes, no, go and stop together with the 2 classes noise and unknown. It is meant to control a robotic arm which is asking if it should perform an action that can be accepted with yes or rejected with no. The movement corresponding to that action can be then started with go and stopped with stop, even multiple times. The second implementation uses the keywords 1, 2, 3, 4, 5, 6, 7, forward, backward, go, stop and the 2 classes unknown and noise. It is meant to control the movement of a robotic arm on its 7 axes. The selection of the axis is done with the keyword corresponding to its number and then it can be moved backward or forward. The go and stop keywords can be used to start and stop the reproduction of movements from waypoints, possibly defined by voice using the previously described strategy for movements. Each use case or scenario implementation requires a specific dataset, customized data transformations in different levels, sample level, dataset level and batch level. Data transformation could be realized by applying changes in preprocessing functions and parameters directly in the internal code of containers. However, this method would be complex for the end user, requiring a good understanding of the internal architecture and admin privileges. Slow, requiring a rebuild of the tool flow. Not easily reusable, requiring some coding and not being modular or storable. To solve these problems, we proposed a modular architecture to enable the end user to define through the graphical user interface, a preprocessing pipeline, composed of modular and reusable steps, and its parameters, modular loss and accuracy metrics, and custom split criteria for the dataset. The ALOHA frontend has been updated to introduce new menus and fields to create and edit preprocessing pipelines. These menus are accessible through the preprocessing column in the section Preprocessing Pipeline. Using the drop-down menu, the user can select an existing pipeline and eventually edit it, or choose to create a new one. Users can define new plugins and new versions of already existing ones by uploading Python scripts together with JSON metadata files that define how each specific plugin should be used in the platform. Moreover, user can select or define custom preprocessing pipelines to accommodate the data and its format for the training and testing phases through a specific configuration user interface. The menu includes 3 columns representing the sections in which the transform modules are going to be applied. Each column contains, in order of application from top to bottom, Cards representing the transforms. The user can intuitively drag and drop the cards representing the transforms to change the order of their execution or the section in which they are applied. Pre-processing operations can be added to one column by clicking on the Add Plugin button and search them or selecting them through the menu. The pre-processing operations order can be changed using the arrows buttons. Moreover, parameters for one specific operation can be set using the pencil button. The ALOHA tool flow with plugins architecture simplifies the exploration of different models and allows to easily compare the effect of different feature extraction methods, MEL spectrogram or MEL frequency cepstral coefficients, and of data augmentation transforms. A total of 27 different models have been trained using 15 different pre-processing pipelines, characterized by different operations and R parameters. The best results obtained for the two selected implementations in a semi-automatic way are comparable with state-of-the-art in terms of accuracy. The proposed modular approach proved to be effective in supporting the exploration of different pre-processing operations and parameters in the KWS use case. It also allows automatic experiment tracking and easy comparison of different configurations. Moreover, a modular architecture also results in the extensibility of the approach to support new use cases, which is a desirable feature to make the ALOHA tool flow exploitable beyond the project's end. In the future, we plan to further validate the methodology with extended automatic pre-processing parameters exploration. Thank you for your attention.